an original.
From Story Studio Network.
I'm Tom Hoppe, and I'm your host of the Most Painful Podcast. On our last show, we spoke to Dr. Dina Ikatar, who's a concussion management specialist and a chiropractor at Health Max Physio Clinic, to discuss support strategies for caregivers and loved ones. Lots of great information on this show, so if you missed the episode, you can listen to it on our Spotify and Apple feed. And if you want to receive the most up-to-date episodes, subscribe to this show. On previous episodes, we have spoken about brain health. We've talked to Dr. Brenda Lau about brain health and some strategies to stay healthy. And today I'm joined by Tanja Yardley, who is the founder of Brain Innovation Network, to talk to us about the latest research on brain health, assessment, and treatments. Tanja, welcome to the show.
Thank you so much. I really appreciate the opportunity to be here. I love what you're doing.
Thanks for your support. Now, you're going to have to tell me a little bit about brain innovation and what it's about. I think we have to start there, and then we can talk about, I know we talked about some of the, when I visited the clinic, we talked about some of the research and some of the cool stuff you're doing. We can get into that later, but let's talk about the brain innovation.
What I might do is reverse that a bit and actually talk about the clinic and how the work that we were doing at Health Tech Connects actually led to the Brain Innovation Network, because it's actually kind of an outcropping of that work. So I've spent the last 6 years working for a company called Health Tech Connects, which is kind of an umbrella. And underneath that umbrella, there are 3 different divisions, and I worked across all 3. So I'm grateful to say that I think I have the most fun and interesting job that I've ever had in my 33-year career as a physio. But one of the divisions underneath Health Tech Connects is a med technology, which is basically a cognitive assessment called NeuroCache, where we look at how the brain responds to different stimuli and norm that against all different kinds of scenarios. But it's a wonderful piece of technology that helps to look at brain health more globally. And then beside that is the NeuroPeak Clinic, which is a neuroplasticity clinic. It's based in Surrey, BC, and we treat all things neuroplasticity, from brain injuries to Alzheimer's and dementia and a variety of other conditions like MS. And we also work with high-performance athletes and execs who are hoping to fine-tune their brain health and function much better in terms of their decision-making, their speed, agility, and all those kinds of things. So I had a really nice broad spectrum of different people that I dealt with there. And then attached to that is the Center for Neurology Studies, which does clinical trials on all things brain health and neuroplasticity related, everything from neuromodulation clinical trials to different medications, looking at nootropics and supplements, looking at brain stimulators, and even things as weird and out there as psychedelics, where a lot of their research is happening right now around mental health and treatment-resistant depression. We're hoping to do some work on concussion and brain neuroplasticity more globally. So it was really interesting because I had this beautiful ecosystem of technology tools that I could play with, clinical staff that are passionate about neuroplasticity, and then this research team embedded alongside. And so we created something called the Flywheel, which in my role there as head of clinical innovation, I would be scouring the globe for different advancements in brain health, and then bringing things into our team to research and looking at research. And then if something outperformed what was in the world today, we had a wonderful opportunity to adopt it in our clinic and get it into the hands of the people that it was designed to help in the first place. But the dilemma that I came up against in that scenario is that NeuroPeak, our clinic, would have access to these tools, and then people who were flying in from all over the world would go back into their home community and they wouldn't have access. And so Brain Innovation Network was kind of born from this idea that we could replicate that sort of system in Flywheel and scale things out into the world in a much more meaningful way to create access for people. And so Brain Innovation Network is the network of clinics all around the world that are interested in brain health and neuroplasticity and working together to advance the science and look at the clinical care models and be able to integrate innovation into everyday life.
That's really interesting, because I remember you gave me the tour of the clinic and just seeing some of the different products that are out there. Maybe you can talk, the one where you're assessing, I guess, the brain itself for if someone's had a concussion, or maybe would it also be if they didn't have an injury? Or is it just, it's an all-purpose type of, so that, I think that was something you said could be by using lights or other stimuli, you can assess the brain in a very short period of time. Was that correct? Have I understood that properly?
Yeah, the technology that I think I showed you when you were there was the neural catch platform, which is just like a stretchy cap that goes over the head that has electrodes embedded. And one of the neat things about that particular tech is that you can get an assessment of the brain in a 6.5 minute period that spits out a report with quite actionable insights in a short period of time, like inside of 10-15 minutes. So one of the neat things about that tech is that we can actually take it out into the world. So it's been on the Lower East Side looking at people with addiction. It's been up Whistler, managing people at Crankworks when they tumble down the hill on their bike, and we can actually assess their brain in real time within minutes of the incident, and to be able to look at how the brain has been impacted. So there's some really neat ways that it gets deployed around the world in various research and clinical settings. So that's one of the pieces of tech. And we often pair that with other types of cognitive assessments. So that really looks at the firing of the brain and the electrical systems. And then we engage lots of other different kinds of brain health assessments to look at how that affects someone functionally. So we might use a computerized test to look at how your spatial orientation is impacted, or whether or not your short or long-term memory is impacted, and looking at all the different dimensions of cognition. And it's interesting because you and I actually intersected not so much on the brain side, but actually on the pain side, and understanding that neuroplasticity is also a core component of a lot of chronic diseases and mobility limitations and chronic pain and all of these things. So being able to apply these technologies, not just to people with brain injuries, but to people whose brain has been impacted by some external circumstances that changes the way they function, is really powerful. And then we use all kinds of other tools on the treatment side. So we have lots of assessment methodologies in our clinic, and computerized foot pads that look at your gait patterns. And we have something called the sensory organization test, which looks like a giant phone booth that actually teases apart all of the components of balance. So we can look at what information is coming in through your somatosensory system. We can look at how your vestibular system, your inner ear, is working. And then we also look at your visual system and how much input your eyes are giving into the whole balance. So one of the other areas that we do a lot of work in is people who struggle with dizziness and balance problems and falls and things like that, just looking at all the different factors that might play a role as somebody is struggling with some of those things. And then in terms of the treatment methodologies, because we're a research lab, there's a constant flow of things crossing our desk. So one of the more interesting technologies that we've used a lot is called the shift wave chair. And that is a group of people that were absolutely fascinated with the idea that different kinds of pulsed pressure waves and vibrations happening in different frequencies and different patterns could actually impact your nervous system. So we work a lot with nervous system regulation. And the shift wave chair can actually upregulate you if if you've had a brain injury and your cognitive processing is slow, or if you are in fight or flight all the time and you're really amplified. You can use certain patterns and frequencies of vibration to actually adjust the way that your nervous system is responding and entrain it over time. So we've had a lot of fun playing with that tool. And then looking at things like neurofeedback, which I know the Atlas Institute, which does a lot of work on the mental health side with veterans, has done a lot of projects around neurofeedback and looking at some of the benefits of that. We have a lot of different sensory tools that we get to use, everything from different types of light and sound and music therapy, all kinds of different modalities that can impact your nervous system and help to regulate your system and also produce state changes. So if you're tired and sluggish, we can make you feel more active and awake. If you're overstimulated and wired, then we can help to kind of settle the nervous system. So we just love in our environment to play with the different technologies and tools that are coming out and then report back on how they're doing.
And yeah, I mean, it sounds all interesting. And I wanted to go back to maybe just starting with the assessment first. When you talk about, using the device in Whistler, using it, after someone's had a concussion and that, what is it showing? So say someone does have a tumble and they have a concussion, what is it showing? And then once that's been determined, whatever it's showing, the symptoms, what is kind of the treatments, or if you do anything, you just let it rest. I mean, I'm just curious how that's all connected. Because I mean, you can see that with a broken arm, right? You see a broken arm, you x-ray it, you put it in a cast, you heal it. You hit your head, What kind of readings are you getting, and then what are you doing with that?
That's an excellent question. And I apologize for those of you out there that this is a tiny little neuroscience, blurb. And I'll try to make it as straightforward as I can when I'm talking about the language of the electrical activity of your brain. But basically, it measures 3 core components of cognitive function. The first one is your sensory perception. So the way that we actually do the test is we put the cap on your head and then we put earbuds in your ears. And through the earbuds, you'll hear a series of sounds. You might hear beep, 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 and then beep, a louder one. And then you'll also hear thrown in randomly word pairs. So it might be dog, cat, salt, pepper, and then all of a sudden Pizza Mountain crops up. So when you hear the louder beep or the mismatched word that kind of violates what you anticipate the next word is going to be, you get a spike of electrical activity. And so these spikes of electrical activity have been measured for literally 100 years. There's probably 150,000 studies on the different, what they call evoked event-related potentials or evoked potentials. So when we stimulate the brain, it behaves in usually a fairly characteristic pattern. So the measurements that we take from that are the latency, which is the speed at which your brain responds in milliseconds. And we also look at the amount of electrical activity in microvolts. So the size of the electrical spike as well as the speed of the electrical spike. And so we'll look at sensory perception. So from the time the sound hits your ear, for example, to you're perceiving that it was a sound and that part of your brain lights up. And then the next part is the attention. So how quickly does your brain attend to that stimulus that's different? How quickly does it recognize that? So that looks at your attentional and orienting system. And then the third thing is more related to the words as opposed to the beeps, and that is your cognitive processing speed. And so each of those is a successive level more complex. So the sound hitting your eardrum and your auditory cortex lighting up is, quite a simple process in your brain. The next one, which is the louder beep, if you equate that to a real life situation, you could be walking in the woods, listening to the breeze rustle through the trees and the sound of your feet on the ground, and all of a sudden, snap, you hear this stick snap behind you, and immediately your whole nervous system lights up. Like, what was that? Is it a bear? Am I in danger? And so your ability to attend and use your attentional system it's really important. And there are multiple areas of your brain lighting up at the same time. And then by the time you get to the cognitive processing part, you're actually looking at memory, the phonetics of a sound. So you'll hear a sound, and is it an ah or oo or o? And then how do those sounds fit together? What word do they make? Do I know that word? Where do I know that word from? Is it in the right context? So then you're dealing with multiple areas, really complex cognitive processes going on. So we can look at everything from basic processing all the way up to the more complex processing work. And so it's really neat when you start to see some of these changes. If someone's in fight or flight, their brain behaves quite differently. So someone who's been in a high alert situation might respond quite differently to that test than another person who hasn't been in that situation. If someone has had chronic pain, for example, and their nervous system has become accustomed over a long period of time to tuning out stimuli, they will behave differently than someone who doesn't have pain. So even though it's designed initially to be kind of a brain assessment and people automatically think of brain conditions, there are lots of other conditions that show up. Schizophrenia has a characteristic pattern. There are lots of other, depression has a characteristic pattern. So it's interesting when you start looking at those different factors and features, you can tell a lot about a person from that little 6.5 minute assessment. And then we just add other things alongside it depending on the person and what they need.
So then if you find, I guess, in a concussion, for example, or any injury to the brain, the signals would be slower, or something would have to work more in order to compensate for that. So that's what you would be seeing on that assessment then?
What we often find is that the brain takes more electrical energy to do something slower. So the latencies get slower, but the amplitudes often get higher because the brain is just working harder, generating more effort to do a task that would normally, be a simple task. And you can also start to see cognitive fatigue in people when they're attending it. Sometimes for the first part of the test, they're performing really well. And then towards the end, they're starting to tail off or they can't hold their attention. And ADHD and things like that also, we can see some characteristic patterns with that test.
So then once you determine that, what would be, so I'm skiing down the hill, I knock my head, which is easy to do because I'm not a good skier. And then what would you, so now you've done the assessment, what would be some of the symptoms, I guess? Let's use concussion, keep it simple. Unless you want to use something different, what would be the next steps on the treatment side?
So one of the nice things is that, for example, a concussion is a great example because often people get really sound sensitive when they've had a concussion, and often that will show up on the scan as, they're overreacting to a very minor sound stimulus. So if we know that and we can see it on the scan, or we see that their attentional system isn't working properly, then we can use some of the standard kind of concussion tools that we would use to help kind of settle the nervous system, sometimes breath work, sometimes visual tasks if their oculomotor system is not working properly. Sometimes if people are really struggling and they can't they're having trouble with energy levels, sometimes we'll use something like the neuronic helmet. I know we didn't talk about that one, but it's a photobiomodulation helmet. It looks like a bike helmet, and it sends near infrared light into the skull.
Yes, we did see that.
Yeah, at 1070 nanometers, which actually stimulates the cell to generate ATP, which is our body's energy system and energy source. So yeah, there's some really interesting things that you can do just to help support metabolic health, because one of the things we know about concussion is that the metabolic health of the cells is impacted for a period of time. And so if we can help to boost that recovery system, it can really be helpful. The other thing too that we always attend to, I'm talking about technology, but really we can't forget the lifestyle medicine side of this, which is, proper sleep, proper nutrition, making sure they're getting properly hydrated and they've got the building blocks for the neurotransmitters that they need to build, and, some of those really basic things. And it's interesting, even with all of the technologies that are out there in the world today, nothing can perform better than, the BDNF that you get released when you exercise, and, making sure that your metabolic systems are working in the rest and repair stage of deep sleep and those kinds of things. So paying attention to the basics first, and then just using the technology to give you a tiny bioenergetic boost where you're stuck, I find is the most helpful.
It always seems, that's one thing I've seen, I hear in this podcast, it always comes back to that, is exercise, good sleep, good nutrition. This is kind of the core that makes the biggest difference. So what about, I'm just curious because we're talking about brain health. If we look at, I guess, veterans, or even probably more veterans, military style, who've had concussion blasts over the years, or just bangs and dings, as you're riding an armed personnel carrier, that kind of thing. And it's cumulative. So what, has the brain shown that it can change and adapt?
Yes.
Or does it actually, lead to dementia, Alzheimer's, or can the brain repair itself and prevent going down that road?
I think one of the most powerful things that I've learned in the last, 30 years is that the limits that we previously thought were there are really not. If you can, one, adopt the right mindset and the habits that you need to really attend to the things that you can affect, that certainly if you catch things earlier upstream, there's a much, faster likelihood that it'll turn around. But even if you've had brain conditions or, chronic health problems for years and years and years and years, we can still see some really, really positive benefits if people attend to the things that matter. And it's amazing the degree to which nutrition, hydration, sleep makes a big difference. I think people have more tools at their disposal than they realize they have. There are some really excellent studies about nutritional supports and particular kinds of diets like the MIND diet and others that can be helpful. In the dementia space, there's some interesting work that was done by Dr. Dale Bredesen around some supplements and different types of interventions there, and they're showing some really positive results. There's some controversy about it, I think, obviously because the drug companies are not super excited about something that's so supplement focused, but there's also like some, and I think that one of the biggest challenges is the quality of the research. There's so much going on in the world today, and so many studies or research projects that are coming out that are claiming all these things. And part of my job in the role that I'm in now is to really curate what is good science versus what is junk science, and helping people kind of navigate this sea of information. But really, like the lifestyle medicine stuff is really well supported by multiple levels of research, and I think extraordinarily helpful. And the technologies are coming along slowly, but surely. A lot of them are new to market, and it's going to take a while to really look at the long-term implications. But the nice thing about a lot of the bioenergetic technologies that we're working with is they're non-invasive. They typically have a low risk profile. The side effects are minimal. There are a lot of technologies that are just kind of boosters, as opposed to, the way that they often treat pain and brain injuries is with really heavy medications and invasive techniques and technologies and surgeries and ablations and all kinds of crazy stuff that I think if you can get back to the basics and get connected to a really thoughtful, well-trained therapist, whether that's a physiotherapist or a counselor or a doctor who does more of kind of a functional medicine type approach, often you can see some really big swings even with the basics.
Yeah, and I as you're talking about that, I mean, there's, you got Huberman, Attia, a number of other those that are out there that are saying exactly that. If your metabolic health isn't good, diabetes, heart disease, it impacts your brain. I mean, it just, so it makes sense to look after your health in a sense. Is there any takeaways that you would want the audience to have as we're coming to the end of this episode?
Yeah, I would say a lot of the light, like photobiomodulation technologies, are interesting to look at and worth looking at. I would say things like creatine, which is fairly simple and is getting more broadly used, is a good supplement. Hydration is really overlooked. I think ensuring good hydration with a good electrolyte that doesn't have a lot of junk and sugar in it can be helpful. Exercise, of course, but there are people that are really limited in their ability to exercise because of their pain or their brain injury. So technologies like shift wave that stimulate some of the blood perfusion and lymphatic flow and those kinds of things can be helpful in the event that you can't exercise very much. There are some ways around that. I also work a lot with Neil Pearson, who is a physiotherapist who does a lot of work in the yoga sphere. And yoga can also be extraordinary, even if it's not the traditional yoga, but just mindful movement and the combining the breath. There's a lot of really interesting work happening right now with brain-heart coherence and looking at managing your heart rate and your heart rate variability and playing into how breath and other things can influence that. So yeah, there's lots of really simple, low-cost tools, and yeah, I think that we are at an unprecedented time where some of these tools and technologies that were previously only in the laboratory environment are becoming more and more accessible to people. And one of the things that I'm really trying to accomplish with the Brain Innovation Network is finding ways to make them affordable and accessible outside of the lab for people. So I'm really excited about that.
Does sound exciting. I think that's because you're right. I mean, if someone isn't living in a major center or they go wherever they live and they don't have access to that, it kind of limits what they're able to do. But as you said, and I think we've heard from many other people, and we've had Neil Pearson on the show talking about breath work and yoga, and so people can listen to that episode. But there are things that people can do at home that don't need fancy machines.
Yeah.
And it's just behavior change, which, as we talked about before, the show gets into the whole neuroplasticity of the brain. That might have to be another episode, Tanya.
I think that would be a fun one. And things like neurofeedback, like I have a whole team of brain health coaches that will coach anywhere in the world anytime. And we can send a neurofeedback out to someone. So it's at a low cost, small piece of technology that you can actually have at home and we can monitor remotely and teach you how to use. So not all of the technologies are big or expensive or you have to go to a clinic for. There are lots of small technologies that we can get into the hands of people as well. So it's, my goal is to really get out there and train clinicians on what neuroplasticity is. The fact that neuroplasticity can be good in that you're doing things that help you function better, but it can also be bad in that you get into these patterns of behavior and activity that actually keep you stuck, and learning how to really harness and master your own brain in a way that's positive for your life is, that's a whole skill set that I wish more clinicians had. And if I have my way, more will have it.
Well, it sounds like you're making progress, which I think we're all thankful for the work that you put into this.
Thank you.
Thanks for being on the show. It's a great talk. And maybe we'll have to look at another show after this.
Yeah, actually, there's 10 principles of neuroplasticity that I love to teach people about that help them kind of understand how to change and rewire their brain in ways that are helpful and easy to do. So that might be a fun one.
I think that is a perfect one. Well, so for the audience, stay tuned for season 7. We're going to have one on 10 ways of, what'd you say?
Rewiring your own brain.
Rewiring your brain. Yes.
Yeah.
I obviously need help with that today too. So
That's okay.
Tanja, thanks for being on the show. I appreciate it.
Thank you so much. Thanks for having me. And I really look forward to collaborating and learning from some of your other guests. You have a stellar lineup of people. I'm honored to be on it.
Well, thank you. And we're glad that everybody's contributed. And that's our goal here, is to, cut through the misinformation and provide evidence-based information for people who are struggling with pain and other conditions. So thanks again for being on the show. For feedback about our show and more information on chronic pain, you can visit our website, veteranschronicpain.ca, or follow us on Facebook and X at Chronic Pain COE, and on Instagram at chronicpain_COE. To the audience, stay safe and keep the hope alive.
The Most Painful Podcast
is produced for the Chronic Pain Center of Excellence by Story Studio Network.